Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here at Synopsys with Scott Durrant. We're going to talk today about co-packaged optics. So, Scott, what's so important about co-packaged optics and what's changing there?
Co-packaged optics is a mechanism that makes it possible to deal with some of the faster Ethernet interfaces that are being deployed today and in future years. So things like 800 gigabit per second, 1.6 terabit per second Ethernet can utilize this technology to provide in a power efficient way fast Ethernet connectivity within data centers.
Let's take a closer look.
Sure.
Scott, what are we looking at here?
This is a chart that shows the progression of Ethernet data rates over the past few decades. And I want to highlight the fact that for the last couple of years, we've seen deployed in data centers 400 gigabit per second Ethernet. And we're seeing today in some of the larger data centers early deployments of 800 gigabit Ethernet. And we expect to see those speeds continue to increase 1.6 terabit per second within a few years and continue progressing beyond. And as data rates increase, the power required to move data also increases.
So, normally when we think about Ethernet, though, you don't think optical signals. How do these two worlds mesh?
So with these fast data rates, it becomes very important to be able to move data in an efficient way. And optics or light tends to be an energy efficient mechanism for moving data at high rates of speed over long distances. And with that, I'd like to show you some of the ways that that has been done in the past and going forward. For the past 30 years or so, we've used pluggable optical modules. These are optical devices that plug into the front of a switch chassis and carry data from the switch faceplate over fiber optics to the destination. It's a very flexible mechanism for data networking. But one of the problems it has is as we get to these very high data rates, the amount of energy required to move data from the switch chip, the ASIC, to the optical module on the front panel of the switch is becoming untenable. At about 8 picojoules per bit in a switch that is carrying 400 gigabit per second Ethernet, that equates to about 100 watts of power within this chip just to move data between the switch ASIC and the pluggable module at the front panel. That's manageable, but as switches increase in speed, this amount of power required or energy required is going to grow to 200 or 400 watts. And that just becomes something that's very difficult to cool. So a few years ago, the Consortium for Onboard Optics released a specification that allowed the optical module to be moved closer to the switch ASIC. It still requires that data be passed over the printed circuit board to that optical module. While doing this, we're able to reduce the amount of energy required to transfer data down to about 3 or 4 picojoules per bit, which is a significant reduction over pluggable optics. But as we get to these very much higher data rates, there's a desire to reduce the energy even more, and that's where co-packaged optics comes into play. With co-packaged optics, we actually move the optical module onto the same substrate as the switch ASIC. And that allows us to move data over a very short distance on a very low loss substrate. And we expect that the energy required to move a bit of data in this environment in a co-packaged optics implementation will be much less than 3 picojoules per bit, which makes it possible to move data at 1.6 terabits per second and beyond.
We've been talking about potentially putting optical in as a way of reducing power and actually heat for a long time. What's changed now? Why is this actually working now versus when we talked about it several years ago?
Well, for one thing, the value of it has become greater. As the data rates increase, we see these very high data rate switches, which can move, we'll see soon 51.2 terabit per second switch silicon, and we expect it to double again with a few years after that. These very high data rates drive a very strong need to reduce the amount of energy consumed per bit to move that data. And so the need has grown significantly over the past couple of years.
We're also dealing with a lot more data than we were in the past too, right?
Yes, that's absolutely true. And that's a very good point. That's one of the reasons it's so important that we have high data rates, is because the data volumes are increasing as we connect more devices to the internet and transfer data between devices. It's the data sphere itself is growing, and so the need to move data quickly is growing.
People have been wondering what's going to be the first major application that really drives a lot of the optics in a package, potentially between packages, and ultimately even potentially inside a chip. Is this the first one that's really happening? We've used optical signals forever when it comes to phone services, for example, and the trunk lines that connect different systems together, but it's never really been down at the chip level.
That's true. And we have used optical networking for many years and data networking as well. But again, just the volume of data and the need to move that data long distances is driving this need for high data rates. And so data networking, I think, is going to be kind of the driver application, the one that really drives us toward co-packaged optics. But I'm sure that we'll see that expand into many other applications as time goes on.
What about the tooling for this? Does it exist? Do you use the same tools as you were using for electrical signals?
The tooling does exist. It requires some of the advanced packaging technologies that are just now becoming practical, so that you can combine into a single package both the switch ASIC and the optical module.
So you think about an engineer designing a chip, typically what they've been working with for the past 50 years or so is electrical signals, even longer than that. They really have no experience in working with optical. Now we're starting to combine two very different techniques here, even though basically we're trying to move data. What has to change? What are some of the problems that they potentially can run into?
I think some of the problems that we face in this area right now are the lack of standards that define how the electrical signals need to move from the electrical devices to the optical devices. And organizations like the Optical Internetworking Forum are driving very hard to establish standards in this space. So I think as those standards form and develop and become adopted, we'll see much more rapid adoption of co-packaged optics.
What's the impact on SerDes?
So as you look at the pluggable optics, it really takes today a long reach or perhaps a very short reach SerDes to drive the data over the circuit or to the optical module. Moving forward to a co-packaged optics solution, because the losses are much lower, actually use an XSR SerDes to drive that data. And that provides another step or another degree of efficiency in these solutions, as well as high data rates.
Does it potentially get rid of the SerDes, or is it going to function with the SerDes?
There are a number of approaches to co-packaged optics under consideration right now. One of those would get rid of the SerDes. I don't know, it's still to be seen if that will be a practical solution or not, but there are certainly proposals on the table right now and that are being considered by the standards organizations to see if getting rid of the SerDes or utilizing XSR is the preferable approach.
So one of the big problems that has to be solved, and it's really the limiting factor in a lot of designs today, is thermal. How do you get rid of the heat? How do you reduce the heat? We've seen a lot of different techniques for this, from giant heat sinks all the way down to potentially even microfluidics. What does optics bring to this table here?
As the amount of energy required to move data is reduced, it helps to reduce the amount of heat that's generated within the system. I have a sketch here that I think might help to illustrate this. Looking at this sketch of a 32 port, a 400 gigabit per second switch, something that's very commonly deployed in data centers today. The total data bandwidth of this switch is 12.88 terabits per second. So again, going back to the pluggable optics solution that consumes about 8 picojoules per bit, to move the data between the switch ASIC and the pluggable optical module, that results in about 100 watts of power and therefore corresponding heat that needs to be removed from this device. Now, these dark boxes represent the optical module connectors on the front panel of this switch. And the gray area shows the area that can be perforated for airflow through this device. Now again, at 100 watts, we can get enough airflow through this switch chassis to cool the devices inside. But when you start to multiply that with the 25.6 terabit per second, 52 and over 100 terabit per second switch silicon, now all of a sudden you've got much more heat inside this box, and it's difficult, very difficult, to move enough air through this chassis to cool the devices inside. So that's where co-packaged optics really helps. If we can reduce that energy consumed and therefore the heat generated by 2 or 3 times, and we'll be able to cool the switch silicon inside this device and continue to increase the data rates for the switch.
What does this do for the cost of the design? So you think about an Ethernet switch, for example, those are generally part of the data center infrastructure, and they are a little bit more price resilient than what you'll see in a package.
Yeah, so the cost is one of those things that will come down as volumes increase. So initially, it may be more expensive than a pluggable optical module, for example, but with the reduction in cost of advanced packaging and the reduction of the optical modules that you have to have in the front of this box, over time, I believe we'll see hopefully parity and maybe even savings with the co-packaged optics solution.
What do you see as the time frame for beginning this transition here? We've been talking about it for years, but it seems to be finally happening.
Yes, and I expect that we'll see switches based on co-packaged optics within the next 2 years. And again, the adoption, I believe, will increase as the technology is proven, and we'll see as data rates increase, greater and greater demand for this type of switch. So expect within the next 2 to 3 years to see these roll out.
And within a data center, this is sort of an easy sell, right? Because they can look at the amount of energy that it takes to push the signals and how much electricity they're using and how much it takes to cool these devices and say, okay, this is going to save us money and therefore it's worth the investment.
That's right. And we've seen networking become a bigger and bigger part of the data center power consumption over the last several years. So they're very sensitive to the amount of energy consumed by network devices.
Scott Durrant, thanks for a great explanation, a really interesting discussion.
Thank you, Ed.